Okay, here's a problem where we're going to practice looking at pulley systems and also practice looking at friction. Okay, so here's a pulley system where this smaller counter mass is pulling on a larger mass that's sliding on a table, and this mu, if you remember, is the friction coefficient between the table and the surface of that larger mass. Okay, so we have to try to factor in all these variables to be able to calculate the acceleration of a system. And remember, with a pulley, we're not just pulling one mass, you are accelerating the total mass of the system. That's the trick behind pulleys. So all those words that I just said, that's just all to get you to review some concepts. And if you didn't catch some of those words, maybe you got to go back into the chapter and review. So friction with the friction coefficient and pulley systems, counter mass, sliding mass, okay? And how are we going to calculate stuff? So the first thing that we got to do is label the free body diagram to find the forces. Then we have to calculate the net force acting on the pulley system. And then after that, we can calculate the acceleration of the system. So I'm not going to do a proper calculation. I'm just going to show you how to set things up. So the first thing we're going to do is we're going to label the forces. So that is going to be the force of gravity. That's going to be applied by the countermass. And then if I look at the sliding mass, there are many forces acting on it. Okay, so you have the force of gravity acting on the larger sliding mass. I'm going to call that little m and big M just to distinguish them. And that force of gravity on that larger mass is going to be, equal to the normal force acting on the surface of that object. And then you have the force of friction, okay, which is going to be slightly smaller than the force of gravity down over here in order for it to accelerate. Okay, and of course we have the force of tension in that rope, which is going to be equal to the force of tension here. Okay, so, and that, sorry, I drew that wrong. That force of tension in that rope has to be equal and opposite to the force of gravity. So that the size and magnitude of that force, the size and magnitude of that force of tension needs to be equal to the force of gravity in order to hold it. Okay, all right, so here we go. We labeled our free body diagrams. Now how do we calculate the net force? Okay, so the forces that are going to be counteracting to accelerate the system is going to be the force of gravity of that counter mass minus the force of friction acting on that sliding mass at the top is going to be equal to F net. Okay, so the force of gravity, that's just going to be little m times the acceleration of gravity minus Fn times mu. That's, if you remember, is how we calculate the force of friction, okay, which is going to be equal to F net. And then we can further substitute things, mg minus capital Mg, that's my normal force, which is equal to the force of gravity on the sliding mass, times mu is equal to F net. All right, now what exactly is F net? F net, according to Newton's second law, is equal to m plus m, okay, the mass of the system, times A. Okay, I want you to just pay attention here. M plus m, because in a pulley system, the entire system is moving. So the total mass of the object that's accelerating is equal to the mass of the countermass times plus the mass of the sliding mass. So m plus m times A is equal to F net. Okay, so if I bring that in, mg minus mg mu is equal to m plus m times A. So if the question is asking me to calculate acceleration, I would just have to rearrange everything. M times g, capital M, g, mu, divided by m plus capital M is equal to A. Okay, my acceleration in a nutshell. Okay, and then that equation, I would just have to substitute all the values if they gave me a problem to be able to solve for the acceleration of a pulley system, factoring in friction. Okay, so just to quickly walk over it, again, you draw your free body diagram. This force and that force are having a tug of war. That's creating a net force. That net force I would use to calculate the acceleration of the system by creating an equation. Okay, F net is equal to the total mass of the pulley system times acceleration. So plugging everything in, that goes here, is equal to that. And then rearranging the equation gives me my acceleration.